So dear students, up to now we see about the net present value and time value of the money and payback analysis and various cash flow models and depreciation and what are the various taxes and tax credits in our fifth unit. So now we will see about the some numerical problems regarding the depreciation formulas. So the first problem is calculate the depreciation rate using the straight line method and sum of the years digits methods for the data given below, where the salvage value or scrap value L is 0 and the life of the equipment N equal to 5 years and the initial expenditure P equal to 1,50,000. So we have different formulas for these numerical problems. I already told in the while discussing about the depreciation methods. So by using those formulas, simple formulas, we can solve these problems. So what we given? P equal to 1,50,000 and L value, scrap value is 0 and number of years is only 5 years only. So that's why there is no scrap. So then the depreciation D is equal to 1,50,000 minus 0 by 5, that is 30,000 per year. So for every year this depreciation will be considered. And while coming to the sum of the years of the digits method, first we find the sum of the digits method, sum of the digits, that is nothing but capital N. So that capital N can be determined by using with useful life of the equipment. So what is the useful life of the equipment? N. So in this problem that N value is 5. So first capital N equal to N into N plus 1 by 2. So 5 into 5 plus 1 by 2, that equal to 5 into 6 by 2, that means 15. So by using this 15, that means N, we can find the depreciation for every year. That means for the first year D1 and for the second year D2 and for the third year D3 and the fourth year D4 and the fifth year D5. So for the first year N by capital N into P. So N is 5 by capital N means 15 into 1,50,000. The answer is 50,000. And D2 is N minus 1 by N into P. That means N minus 1 means 4 by 15 into 1,50,000. So 40,000. And next 3 into 10,000, 30,000. And 2 into 10,000, 20,000. And 1 into 10,000, 10,000. So these are the depreciation values using the sum of the years of the digits method. So in the previous, every year constant depreciation, that is 30,000. But here different depreciation values. That is the difference between those two methods. And second problem, the equipment in a power station costs 15,60,000 and has a salvage value of rupees or scrap value 60,000 at the end of the 25 years, and determine the depreciation value of the equipment at the end of the straight line method and diminishing value method. So the sinking fund method at 5% compounded annually. So by using, we can find the depreciation value of the equipment by using straight line method and diminishing value method and sinking fund method. So let us see the for different methods. So what they give? P is equal to 15,60,000 rupees. So total investment, and the scrap value or salvage value is 60,000 and N equal to 25 years. And for what we consider, for 20 years we can find the depreciated value. So first we find the depreciation value for 25 years, and then that will be applicable to the by using from that formula, from the depreciation we can find the for 20 years. So we know the one formula, annual depreciation is equal to P minus S divided by N. So P equal to 15,60,000 minus 60,000 divided by 25, then we get 60,000. So for every year there will be reduction in 60 years, 60,000. So like that, how many years that will be depreciated? 20 years. So 20 into 60,000, and this will be subtracted from the total investment cost. Then we can get the depreciation value at the end of the 20 years. So P minus annual depreciation into 20. So 15,60,000 minus 20 into 60 lakhs, that means 12,60,000. Finally we get 3,60,000. and the diminishing value method. We know that D equal to 1 minus L by P whole to the power of 1 by N, where small n is this is not the capital N, this is the small n, and the small n is for the useful life of the equipment, and P is the initial investment, and S is the salvage value or scrap value. So by using the formula, the depreciation value equal to 1 minus L by P whole to the power of 1 by N. By substituting all the parameters, we get 0.122, and by using this D value, we can find the depreciation after 20 years by using the formula P into 1 minus D whole to the power of N. Then the depreciated value is 1,50,615. So in the previous 3,60,000 depreciated value. So now 1,15,615. And sinking fund method. For the sinking fund method also we have the formulas. So but in the sinking fund method, for the sinking fund, every year we have the interest. So we have to have the that interest also. So that interest is nothing but here 5%. So sinking fund Q is equal to P minus L into R by 1 plus R by whole to the power of N minus 1. Here also small n. The small n is nothing but the useful life of the equipment. So by substituting all those values, we can find the sinking fund value 31,433. So by using this 31,433, sinking fund after 20 years equal to another formula Q into 1 plus R whole to the power of N minus 1 by R. So substitute that Q 31,433, then we can get the sinking fund after the 20 years, that is the 10,39,362. So the value of the plant after the 20 years is 15,60,000 minus 10,39,362. So finally we get the value after depreciation is 5,20,638 rupees. And the third problem is a transformer costing of 90,000 rupees has an useful life of 20 years, and determine the annual depreciation charge using the straight line method. Assume that the salvage value of the equipment to be 10,000. So initial cost is given 90,000 and the salvage value given 10,000, and the number of useful life is 20 years. So simple formula P minus S by N. So 90,000 minus 10,000 by 20, we will get the 4,000. This is the annual depreciation charge. And coming to the fourth problem, a distribution transformer costs 2 lakhs and has a useful life of 60 years, small n, and P 2 lakhs. If the salvage value is 10,000, the rate of annual compound interest is 8%. Calculate the amount to be saved annually for replacement of the transformer after the end of the 20 years by sinking fund method. So we simply use one formula P minus S into R by 1 plus R to the whole to the power of N minus 1. By substituting these values, we will get the 4,153 as the sinking fund value. So these are the problems regarding the depreciation. Thank you.